Hello and welcome back. In this video we'll cover version control with Git. So first of all, why should we use version control? We could just develop, in the simplest case, from a local directory and keep all the files there, or have a Jupyter notebook that runs somewhere. But then we don't really know what did we change when, and if we encounter a bug, was it always there, or did we introduce it in a recent change, and how do we mitigate this? It also becomes very difficult to collaborate with others if we have a structure of files within folders and files and so on. We would have to sort of synchronize and replicate this with all the others. And so we need to have a mechanism to do this. And in case of research or open source, we also want to let others benefit from our work. So version control is one way to solve these issues, and it's in a nutshell, a way to keep track of changes of our code, when we changed what in the source code, when we added new files or removed others. We can also have additional comments when we commit such a new file in a new version, and we can also revert changes later if necessary. It has the benefit of allowing collaborative work because we can use this to sync changes in a central repository. We can also see who is working on what and what they changed, and we can publish code in public repositories. Nowadays, Git has become the de facto standard. It's very powerful and has many advanced features. It is, however, sufficient to use a small subset for now. So we see on the illustration on the right that we have a file that we want to track, and then we add it to the repository and we add some notes to it, and then we keep working on this file, and then there are like snapshots where we commit to this repository and say, okay, here is a new version, and then this Git repository keeps track of what was changed and when and by whom, and we can also add some notes to it, illustrating what we have done and why. So the simplest way is to start a new project. We have two alternatives here. We can either use a web repository like GitLab or GitHub and so on, and we have to choose if it's publicly available or private for us, and then we can initialize it from the server. Or we have a local directory structure here and then initialize it. For example, we could say with the package manager poetry new my new project, and that creates a new infrastructure like a directory tree of it. Now we can initialize this by going to this directory structure, say git init with the initial branch equals to main, and this will initialize the git setup. And then we need to add it to some central repository, for example, one on a Git server. And then we sort of commit this empty directory, so we initialize the setup. Another way is to clone a remote repository. So if a code already exists somewhere and we want to work on it locally, we click on the clone button. There we have different ways. We can have a URL-based approach or an SSH-based approach, or we can also do it from within the IDE, provided we have entered our credentials, so we're allowed to use this. So for example, we can say we want to clone a directory from a remote repository. So we essentially what we want to do is we create a local directory, we copy over all files from that remote repository and connect the local directory with the remote repository. And this is what the git clone command does. So we say, for example, git clone, and then we give it the address of this remote repository, and then the Git will essentially copy over the file, set up the appropriate directory in infrastructure, and now we can work on it by adding new files, modify files, keep track of changes, and so on. To understand a bit how Git works, we look at the life cycle of a file. So for example, we can add files or modify the source code, and then we need to commit it to the repository to persist those changes. So say we have a file 1py that is initially untracked, so it's for example new. And the life cycle is we add this to the repository, then it becomes a tracked file, and then we commit our changes to the repository. Now it's in a modified state and it's staged, and now we can then push this change to the central repository. So the most useful commands that we know we'll use in the next few steps are illustrated here, and this illustrates the interplay between our local environment indicated by this computer screen and the remote server indicated by the cloud. And the relevant commands affect our local and remote environment in a different way. So git pull or git clone makes a sort of a copy and pulls the file from the remote repository. If we add a file after we modified it, for example, or added a new file, we use git add, and that puts it into the staging area. We use git commit, and then we have added this to the git repository, but only to our local version, and we need to use git push to put it to the remote server. There are also some advanced functionalities like git stash, where we can sort of move files around and edit on several ways, but the simplest way to use Git is to focus on these commands at the top. We have our local structure, and then when we add a new file or modify it, we use git add, then we use git commit, and then we use git push. This is enough for simple use, and that will already get you a long way of using a version control system. So for example, say we have a new file, and this is very simple, right? It just prints hello world. We add it to Git using git add, our example file, and we can use git status to see what it does. So we see that we have it here. We have changes that need to be committed. We have a new file that Git has identified. We also have untracked files. This is done from poetry in it and not yet included, so we really need to add that as well. Now we need to commit our new file to the server. So we say git commit and give it a comment, for example, initial commit. And then we have, okay, one file has changed, and this is example py, and git push sends it to the remote Git repository. Then we edit the file, right? We modify it and maybe write my first edit. Now we can also use diff, and Git then remembers what the current state is and compares it to the previous one. And we can say what is the change that we have done, and Git identifies that we've added this second line. Now we do the same things again. We can check the status and do git add again, git commit, git push, so it's always the same sequence of commands. We can also look at the file history and see who has changed what. We can say git log, and then that will really give us a detailed information of what we have. You can see these funny long strings here. And these are unique identifiers for each commit. You can also have a more compact version that shortens this funny identifier and gives it a more compact view. And this allows us to keep track of who changed what and what has been done to each file. Maybe sometimes we made a mistake, so we need to restore a previous version, right? So we could show the file, and this is where this funny long string comes in. We can use the short version of it and use git show for this ID. This is called the commit ID on this specific file, and we can see, at this ID the content of the file was this, and we can restore it with git checkout at this specific version. We can then commit the changes again like any other edit really. Very, very important, never hard code any code secrets. Never add any sensitive information to your code like password, API keys, authentication tokens, whatever it is. Because as you've seen, Git keeps track of everything. It's almost impossible, not quite, but it's very difficult to remove sensitive information once it's been entered to the repository. And as you've seen, it's not enough to just rename, remove or edit the file, because Git will keep the history forever. Now moving on, tagging versions is a neat way to create releases of a software, for example. We want to create defined states. So when we say, okay, you can use my software, dear user, we want to give it a version like version 1, version 2, but it's also a good practice for ourselves. For example, if we work on our research project or thesis, to give it tags and say, okay, this version has done this. This decouples the actual development we have at the moment, the so-called head, from the controlled code, for example, that we want to give to the users. There are two versions of tags in Git. One of them is the lightweight and one of them is the annotated. The light one is really just a pointer to a specific commit without any further information. Remember this funny long index that is created with each commit. So the tag is essentially a human readable pointer to this. And we can use also the annotated one that stores a bit more information about the commit, the author, and so on. We use the command git tag for it, and then we can enter the relevant information. And then when we look at the logs, we can also see that the software may or may not have tags at specific versions. So far, we've just assumed that we have the rights to clone a repository and commit changes. And this is the case for public repositories that we can clone but not edit, and our own repositories, but they are not necessarily public. We may want to restrict this to a group of developers, so we need to think about access control. That means who is allowed to work with a repository. One good way of doing this is using SSH keys. So we need permissions to read private repositories, save changes, and most setups actually favor or require the use of SSH keys. If you work on Windows, you can use OpenSSH or the Windows subsystem for Linux. If you work on a Mac, you can install it in a terminal environment, for example Homebrew, and you can also look it on GitHub Codespace. So this is what we do here. We generate our key with the SSH-keygen command. This will generate us a public key in a directory called .ssh id_rsa.pub. And this is the public key that we can use and enter into the repositories that will identify us. It's really like a key to a door. So we add those keys, and for example we can do it in GitLab. There is a setting where we use SSH keys and we copy and paste it in here. You can reach this page from the RWTH GitLab, for example, by going to your own profile, click on preferences and then on SSH keys, and you copy and paste your public key. Never ever paste your private key. So far we've done a very linear development. We modify our files, we commit our changes, and this is totally fine for one developer working on different files, and it's also okay for a small group. But in larger groups, or if we want to work together, we typically have multiple developers and we need to avoid conflicts between them. So this is where we can create branches to work independently. And then we put out a so-called pull request to merge those branches. So compared to what we had before, we had one file and it was linearly tracked. We sort of open another line and say, I work now on this branch and you work on that branch, and later on we need to merge our changes. And Git is very powerful, and one of the large functionalities from Git comes here to create and merge branches. So as you can see, Git is very complex and we've just really scratched the surface. But start using it anyway. Continue to expand your skills. Use it locally, even if you're just one developer, and use it to track your progress. And then if you work in larger teams, use it later with more advanced functionality.